Hello everyone, welcome to Indomitable Tech. This is your AIML consultant Shaunak, back with another data visualization video. This will be the last video in the series. In this notebook, we'll be focusing on Altair. Altair is a library based on Vega charts. So I have kept this notebook on GitHub. I have made two notebooks. One is Altair solved, in which we'll be preparing the graphs. So you will have all the code in the solved one, and also there will be one unsolved notebook as well. So unsolved notebook, it will have the instructions for executing the code, but it will not have the code itself. So if you ever want to practice on yourself and get those subtle hints, you can refer the unsolved version. And if you still get stuck, you can always refer the solved version. Both these notebooks will be kept on GitHub, and let's dive in. So in this notebook, I have kept these two links for Altair, where you can see the Altair data documentation. So these two links should help you to give more information about Altair, how to plot the graphs. In this particular notebook, we will be focusing on 9 graphs in total. First one will be the scatter plot, next area plot, then bar chart, then heat map, histogram, image chart. So on image chart, you can plot different images on x and y axis. Then line plot, pie chart, and then pair plot. So these are the most popular types of graphs which you can plot using Altair. So most popular as in these are the most common graphs. There are other types of graphs which you can plot using Altair as well, like choropleth. Then you can also plot funnel charts. So you can find those charts on these documentation pages. So the libraries that we'll be using will be Altair Vega datasets, because we will be making use of datasets for demonstrating the different charts. Then NumPy and pandas. So NumPy and pandas will be making use for in preparing the datasets. You can skip this particular code block. This code block only prepares the datasets that we'll be using to demonstrate the graphs. If you want to refer the code, you can do so in their notebook, which will be kept on GitHub. And don't worry, for every graph that we will be plotting, I'll be showing you the dataset that we will be making use of. Also the data types. So there are in total 5 data types which are used in Altair. First one is ordinal. So ordinal are any ascending or descending values. So it can be alphabets from A, B, C, D, because they follow a specific order, or rank first, second, third, fourth, or list of years, let's say from 2000 to 2010. So it will be 2000, 2001, 2002, and so on. Then quantitative will be any continuous numeric value, like mark obtained by students in class or stock prices, etc. So there is no particular order. The values can be any values, like a person can get, first student can get 50 marks, second student can get 60, third student can get 30, and so on. Nominal values, so these are labels, names, class. So these are not quantitative values. They can be quantitative if but you can interpret them as nominal. So basically nominal values, they do not have relation with one another. So for example, nominal values can be name of the countries, or it can be name of the colors. Then temporal is based on date time values, like dates or hours. And the last one is I have not mentioned it over here because I have not made use of it. It is geospatial values. So it can be latitude and longitudes. So in Altair, if you want to represent the geospatial values, you can do it so by using the G alphabet. Now let's move on to our first plot, which is the scatter plot. So Altair follows this particular format. So it is alt for Altair dot chart. In chart, you have to pass in the data frame, and after that you have to tell what sort of graph you want to plot. And once you tell it that, then you have to tell the encoding, that is what you want on x-axis, what you want on y-axis, and then you have to tell if you want to differentiate using the color, you can do so it in color. And this particular tooltip is, if you hover the cursor on that particular value, then a tooltip will appear. Tooltip as in an additional information will appear on that particular point. That information will be what you have passed in over here in this particular list. And lastly, properties, where you can give in the title of your graph and also the height and width of the graph. So for every graph I have given this format to plot that particular graph, and also the example that I'll be making use of, I have mentioned it over here. So let's see how this particular data set appears for scatter plot. So this is the particular data set, name, miles per gallon. So we have vehicles over here, then cylinders, displacement, horsepower, weight in pounds, acceleration, year, origin and unit. So what we will be doing, we will be plotting this scatter plot, and on x-axis we'll be making use of this horsepower, and on y-axis we'll be making use of this miles per gallon, and we'll be differentiating it based upon the color. So origin, will be making use of this origin, so it is USA and 2 other countries, we'll see that in the graph. And then lastly, the tooltip that we can see when we hover over with our cursor, so that will give the name of that particular vehicle. So plot the scatter plot, so it will be ALT for Altair, and then in chart you have to pass in the name of the data frame, which is scatter df, and then you have to tell it what type of graph you want. So mark, we will choose point, so all the scatter plots will be represented by different points. And then we will pass in encode. In encode you have to pass the values of x and y, color and tooltip. So x will be our first quantitative value, which will be horsepower, and on y-axis we will take the second one, which is miles per gallon, which is again a quantitative value. And then we will choose color as per the origin, which is origin is a nominal value. And tooltip, we will pass in the list. So tooltip will basically show information when you hover the cursor over that particular point. So in tooltip, if you pass in the name and hover over this particular observation, it will show name as Chevrolet Malibu. Not sure if I pronounced it correct. So basically, if you pass in 2 values, it will show 2 values. If you pass in 3 values, it will show information for those 3 values. So basically, if you pass in name, miles per gallon and cylinders, it will show this particular name, and then on second line it will show 18, and on third line it will show 8. For demonstration purpose, I will only pass one value, name as nominal value, and then lastly we will pass in properties. You can give the name to your graph in properties as title, so we will give the name as scatter plot. And here if you see, we have got this particular scatter plot, and if I hover over these particular values, so if you see, so I am getting this Ford Gran Torino, the name of that particular point. This is Oldsmobile, then this is Ford Maverick, and so on. So now this is how you can plot scatter plot. However, if you see, on x-axis the name given is horsepower, and on y-axis the name is miles per gallon. If you want to change the names of your x label and y label, you can do that as well. You just have to pass in for x and y value. So x will be alt.x, and in that you have to pass in the name of the column followed by axis equal to alt.axis, and here you have to pass in the title. So for x-axis, instead of horsepower, if I want to write HP for horsepower, and similarly for y it will be alt.capital Y, and then in that you have to pass in the name of the column from the data frame followed by axis equal to alt.capital AXIS, and then title will be, so miles per gallon, let us give it MPG for miles per gallon, and execute. So if you see, this horsepower which was appearing earlier has changed to HP, and miles per gallon has changed to MPG. So that's all for scatter plot. If you want to increase the height and width, you can do that. So if I want to increase the width, I can do that. I'll increase it to 800 and then height to 500. So if you see, the graph has increased, the height and width has increased. So for better fit, I'll change it to 500 as width and 300 as height. That's all. If you want to download it, you can click on this burger menu, these three dots, and you have these options: save as PNG, save as SVG, view source, view compiled Vega, open in Vega editor. If you want to download as PNG, you can click on here, save as PNG. Now moving on to next, area plot. So format remains the same, alt dot chart, wherein you pass in this data frame followed by area, mark underscore area. So it will tell it is an area plot, and then in encode you have to pass in x and y values, and then color you can name the color based upon the nominal value, and then properties will include title, height and width. So let me show you how our area data frame is appearing. So it is basically year, then origin, and then unit. So origin, let me show you the entire. So in total we have these many values from 1970 to 1982, and for all these three origins, so Europe, Japan and USA, and their particular units. So this is the data frame, and then we'll be plotting area plot. So on x-axis we'll be having this year, and on y-axis we'll be having these units, and the color will range upon origin. So alt dot chart, and here you pass in this data frame, area df, and then mark underscore area, because we want to plot area plot, followed by encode. And here we will be passing on x-axis, we have this particular year, which is in date time format, so I'll be passing t over there, and on y-axis we will have this unit, which is a quantitative value, and then color will be as per this nominal value. So origin will be the nominal value, and followed by properties. Here will be pass the title as area chart, and let us execute it. So if you see over here, we have got this area chart. Blue is for Europe, red is for USA, and orange is for Japan, from 1970 to 1982. So this is how you can plot area chart over here. And on x-axis we have year, and on y-axis we have unit. Now moving on to bar chart, the only difference that you need to make is change from mark area to mark bar. And there are two types of bar charts, stacked and unstacked, that we will be focusing on. First we will be plotting this stacked bar chart, and then we will be focusing on unstacked bar chart. So difference between stacked and unstacked is, for stacked you have different values stacked one above the other, and for unstacked you will have different values placed next to one another. So first we'll plot the bar chart for stacked format. So if you see over here, format is Altair dot chart, where you pass in the data frame, then mark underscore bar, and then encode. X-axis will take the temporal value, that is date time value. On y-axis will take the quantitative value, and the color will vary upon the nominal value. And then properties is used to enter the title of the chart and height and width. So let us see how our data frame appears. It is exactly similar to the one we saw over here in area chart, year, origin and unit. So first let us plot for stacked chart, and here we will pass in the data frame, which is bar underscore df, followed by mark bar, and here you pass in the size. So size should be an integer. So for our example, let us give the size as let's say 20, followed by encode. And on encode, for this particular example, on x-axis we will be taking the year, which is a temporal value, and on y-axis we will be taking unit, which is a quantitative value, and then color will be as per origin, which is a nominal value. and then we'll not pass any tooltip. We'll pass the properties. So properties will have the title, which is we are plotting the stacked one, so stacked bar chart, and execute. So this is how our stacked bar chart is appearing. Red one for USA, orange for Japan, and blue for Europe, our stacked bar chart. Now moving on to the unstacked one, it is the only difference, you have to pass in the columns for the unstacked one. So the format remains alt dot chart, where you pass in the data frame followed by mark bar, same as above, and then in encode you pass in on x-axis the nominal value. So now nominal value in this case will be the origin, and then on y-axis you pass in the quantitative value. In this case it will be the unit, and then color will be as per the nominal value, which is the origin, and then you have to pass in another value, column. So this is the different thing which you have to do for unstacked bar chart. So column will be as per the temporal value, so based upon the year. That's the only different thing that you need to do. So if you can directly copy the entire thing and then paste it, and now I'll tell you where you need to make change. This year you have to remove it from here, and on y-axis we will pass in origin, which is a nominal value, and then after color you also have to pass in the column value, and this column value will be the year format, and instead of stacked it should be unstacked. And this size we will reduce this size, I'll tell you why. So upon plotting, if you see over here, this is the size as 5 and this was the size as 20. So if we increase the size to 20, this particular graph will take more, the width will be increased. So it is showing different years as different columns. So if you see over here, this is the first for 1970, this is for 71, 72, 73 for different origins, Europe, Japan, USA, and these are the units on y-axis. So year on x, y axis shows the unit and different colors based upon the country of origin. So this is for unstacked bar chart. The next chart we'll be focusing on is heat map. So heat map will take the parameter as mark rectangle, and then you encode the x and y values and color as per the third value. So if you see the data frame over here, in x and y I have the ranks from 1 to 10. There are in total around 1000 rows in this particular data frame, and z gives the third quantitative value. So on x and y axis you can pass in the values as quantitative. Here in this particular example I am choosing to mark them as ordinal values because I have given ranks from 1 to 10 in for x and y. So let us plot this particular heat map. So it is alt dot in chart, you pass in the name of the data frame, heat df dot mark underscore rect, and then encode x will be x and I will be passing it as ordinal value, and y it will be y, again ordinal, and then color as per z value, which is I'll be treating it as a quantitative value, and then properties, just to give the title to our heat map. And there you go, our heat map is plotted, and the intensity, the color intensity tells the value of z. So here since it is dark, the value is around 10. Here it is less dark, so maybe around 6 or 8. Here it is white, almost white, so it must be around 2. So that's how you can plot heat map with color. Next plot that we'll be focusing on is histogram. So this is the data frame that we'll be focusing on, hist underscore df. It is name, that is the name of the cars, miles per gallon, cylinders, displacement, horsepower. This particular data frame we have seen in one of the examples above. So let us plot the histogram. Histogram is similar to bar chart. The only difference is instead of considering two values, we'll be focusing on only one quantitative value, and then we'll be focusing on the count of that particular value. So alt dot chart will pass the name of the data frame followed by mark underscore bar, because histogram is basically a bar chart, but we'll be focusing only on one value. And then encode x will be, for this example, we'll be focusing on weight in pounds, lbs, which is a quantitative value, and then on y-axis we'll be taking the count of that particular value. And then we will be giving our chart a name, so that comes under properties, and title will be histogram. So this is the histogram that we are getting, and if you want to increase the thickness of these bars, you can do so by increasing the size. By default, I guess the size is 5, but if you increase it to 10, you get a thicker histogram. So that's all for histogram. You can increase the height and width equal to, let's say, 600, and height equal to 300. So this is for height 300 and width 600 histogram. Now moving on to the next chart, it is image chart. So basically you can plot images on x and y axis. So for this I have created this particular data frame. What we will be doing, we will be plotting age versus overall. So age is the age of the player, and overall is the rating of that player. So we'll be focusing on FIFA 22 dataset, and from that we will be focusing on Portuguese players who are playing for the club Manchester United, and the images that we will be plotting are kept at this particular URL. So URL parameter is needed if you want to plot the image. So at least the address needs to be passed of that particular image if you want to plot image chart. So this is the format: alt.chart dataframe.mark image, and here you have to pass in the height and width of that particular image, and in encode x-axis, y-axis, these two quantitative values. For this example, I'll be considering the quantitative values, and the URL will be this particular column, player underscore URL, this column. And tooltip, for this example, we'll be passing the tooltip as short name. So when you hover over that particular image, this name will appear. So let us plot it. alt.chart image df, the name of our data frame, dot mark underscore image, and height equal to 50, width equal to 50. Then encode x will be on x-axis, let us take age, which is a quantitative value. On y-axis it is overall, again a quantitative value, and then URL, player underscore URL, and then tooltip. Let us if we hover over that particular image, let us see the name of that particular person, and then properties will pass in the title as image chart, and here it is. We have got this particular chart. So if I hover over it, we are getting the short name as Diogo Dalot. His age is between 20 and 25, around 22. This is Bruno Fernandes, and this is Cristiano Ronaldo. And x-axis we have the age, y-axis we have the overall, and right now we are only getting the short name. And if you want to see age and overall as well, we'll just add to this particular list age and overall. That's all, the name of the columns, and then execute it again. And now if I hover over here, I am also getting the age and overall along with the short name. Cristiano Ronaldo, age 36, overall 91. Bruno Fernandes, 26, age and overall 88. For Diego Dalot, it is 22 and 76 is the overall. That's all for image chart. So make sure you have the address of that image that you are going to use, player URL, in this particular example. Now moving on to line plot. So line plot is basically when you plot two quantitative values against each other, or if you want to plot one quantitative value against an ordinal value. So let us do that. So on x-axis you need to have an ordinal value which follows a particular order. So in this example, let me show you. I have this particular data frame where I have the year, and on y-axis I have the year, and on another column I have this miles per gallon. So it is basically miles per gallon for every year, 1970, 71, 72. If you scroll over at the top where I have prepared these data frames, so line plot, it is grouped by year, and I have considered the sum for all these miles per gallon for that particular year. But since our point of focus is how to plot the graph, let us just focus on this particular data frame. So on year column I have the year, and on miles per gallon I have the quantitative value. So let us plot. Format remains alt dot chart, and here I'll be passing line df dot mark line and then encode. On x-axis we will be taking year, which is a temporal value. On y-axis we will be taking miles per gallon, which is a quantitative value. And then tooltip, we can add let's say year and miles per gallon. So when you hover the cursor over the line, it will show the year as well as the miles per gallon value. And then properties, if you want to give your chart a name, so title will be line chart. Execute. So this is how it is appearing, the line chart. On x-axis we have year, on y-axis we have miles per gallon. Dot interactive. Yeah, so after passing the interactive, I am getting the values on this particular graph after I hit the interactive. You can also move it. So basically the graph becomes interactive. So if you see over here, I am also getting the year and miles per gallon, 1979 and 7 to 7.7. Now moving on to pie chart. So we'll be focusing on two types of pie charts. One is the simple pie chart and second one is the donut pie chart. The only difference is when you are plotting the donut chart, you have to pass in this inner radius, which should be an integer. So let us see the data frame that we will be focusing on. It is origin. I can remove this head because we only have 3 rows. Total manufactured counts. So USA has 254, Japan 792 and Europe 73. Format remains alt dot chart, where you pass in the data frame, then dot mark underscore arc. Then in encode you pass in the value of theta, which is the quantitative value, and color as the nominal value. So in our particular example, this theta value will be the count, which is a quantitative value, and the color will be this origin value, that is the name of the manufacturing location, either USA, Japan or Europe. And in tooltip, not necessary, but you can pass in both these values. That totally depends upon you. So let us plot the pie chart first. So alt dot chart pie, then mark underscore arc, since it is going to be a simple pie chart, let us not pass any values. Then encode theta equal to, our first is the count, which is a quantitative value, and then color as per the origin, which is a nominal value. And then tooltip, not necessarily, totally depends upon you whether you want to enter it or not. So I will pass in origin and count. And then properties, just to give our chart a title. So properties title equal to pie chart, and executing it, I am getting this pie chart. So upon hovering over it, since we have passed in the tooltip, I am getting these values: Europe 73, Japan 79, and USA 254. Now the same thing we can do to get a donut chart. So I have just copy pasted it instead of pie, donut chart. And the thing that I'll be passing it over here, I have written it in the formats over here. So this inner radius, this parameter, we have to pass in this parameter, mark arc. Inner radius, let's say 5, and instead of pi it is now donut, and this is the donut chart. So you can increase the size, so 50, so this is a bigger donut chart. Up to 100 it will remain inside this box. Above the 100 value, it will come outside that particular bounding box. So if I keep it to 90, so this is the 90. If I increase it to 150, so it will not show any chart properly, because the inner circle, inner radius is coinciding with the outer one. And if I increase it to, let's say, 200, the inner radius is actually going outside the outer radius, so it is basically inverted, and hence it is appearing outside this bounding box. So easier way, recommended way, is to keep it around 100, so you get this perfect donut chart. Now moving on to our last one, which is a pair plot. So pair plot basically plots comparison of, let's say you have 3 values, so it will give you a scatter plot of all the values plotted against one another. So format remains alt.chart, where you pass in the data frame, then mark underscore point, and encode x value, y value. So in x and y, this time you have to pass in as columns and rows, because you will be plotting these individual graphs against each other in a grid manner. And color, we can be nominal based upon your nominal value. Tooltip, that will be the list of attributes that you want when you hover over that particular value. And then in properties, you can pass in the title of your chart, height and width. And then in this particular repeat method, you have to pass in the name of the row and column that you want to pass, that you want to plot the graph against one another. The data frame that we will be considering for pair plot is the cars data frame, which we saw above in 2 or 3 examples. So name of the car, miles per gallon, cylinders, displacement, horsepower. And now let us plot the pair plot. So it is alt dot chart, and name of the data frame pair df dot mark points, because we are going to plot scatter plot. And then encode x will be alt dot x, and then in that alt dot repeat, and first one will be column, and the type will be quantitative, because on columns will be having quantitative values. Then the same thing we'll be doing for y, and then alt dot capital Y, and here instead of column it will be row. Again type will be quantitative. Then color will be as per this origin. So we have 3 values in origin: USA, Japan and Europe. So origin is a nominal value, and then tooltip. When you hover the cursor over that particular point, you can get the name of that particular car, and if you want to add any other values, you can add in this particular list. So those values will reflect on your cursor when you hover the cursor over that particular point. Then followed by properties. Here you can give the title of your graph, which will be pair plot, and you also have to give height and width of the individual scatter plots, which will make your overall pair plot. So since we are going to plot 3 by 3 values, so horse plot, acceleration, miles, so total we will be getting 9 scatter plots, and for these 9 scatter plots, each scatter plot will have height and width as 200. So I am passing it over here, height and width equal to 200. And then lastly followed by repeat method, where we give in where we pass in the list for row and columns. So this is the list that will be passing in, and that's all. So if you see, we have got this pair plot. So horsepower versus acceleration. So here first one, the y-axis is of horsepower, and x-axis, first one horsepower versus horsepower, then horsepower versus acceleration, and then horsepower versus miles per gallon. On the next one we have acceleration on y-axis and horsepower, acceleration, miles per gallon, and third we have miles per gallon on y-axis, and then horsepower, acceleration, and miles per gallon. So this is 3 by 3 pair plot that we have received based upon the list of these values: horsepower, acceleration, and miles per gallon. So that's all for pair plot. So to conclude the session, in total we have seen 9 charts which we have plotted using Altair. So first we saw scatter plot, followed by area, then bar chart, heat map, histogram, image chart, line plot, pie chart, and pair plot. So if you want to see the detailed documentation, you can see this, you can refer to these 2 links. This notebook will be kept on GitHub. The link for GitHub is mentioned in the description. This was part of the data visualization series. You can refer the playlist in the description. I'll be mentioning the link to the playlist as well in the description. If you found this particular video helpful, do let me know in the comment section. This was your AIML consultant Shaunak, and I'll be signing off. Thanks.